Vegas, Nevada. This is videotape number 22, Wireless LAN Security.
I hope. Okay. Thanks, Jack. As he said, my name is Mandy Andress, president of ArcSec Technologies, and I'm going to talk to you this morning about wireless LAN security. And what the focus is not how to crack WEP, not how WEP works. It's using and knowing about the vulnerabilities and the issues with WEP and how to mitigate those concerns and how to try and implement a wireless LAN in your organization in a semi-secure manner, hopefully as secure as possible. So to do that, I'm going to talk about these few standards, talk about the uses and benefits briefly. Why do you want a wireless LAN? Go over that quickly because most people already know that. Standards, there's a wide variety of wireless LAN standards. Going to go over some of those, how they work, talk about the interoperability of those, and a little bit about what the future holds for wireless LAN standards and implementations. Then going to discuss the functionality of wireless LAN. It differs a lot from Ethernet in the packet size, in the communication, and how the whole structure works. So we'll touch on that and discuss that. And then go into the security issues and solutions and implementations. Talk about what some of the issues are, why the security standards don't work very well. Talk about some conventional and not so conventional ways that you can work around those standards and have a secure implementation. So start off, uses. Why do you want to use a wireless LAN? Key driver, mobility, and accessibility. They're easy. Pick up your laptop, wander around the office, plop down wherever you want, do your work, and easily change work locations. Go to a conference room, pop over to your colleague's cubicle, desk, internet access at airports, conferences like the wireless LAN set up here at the conference, cafes, pop into your local Starbucks, sit down with your laptop, enjoy your Frappuccino, and do your work. So for an organization, what are the benefits? Increased productivity. Instead of having to unplug your network connection, go to the conference room, reconnect, restart your laptop, wait the 5 minutes it takes for your Windows 2000 Professional to boot itself back up. And the ability to work in more areas. Some areas, whether it be a factory floor, a warehouse, aren't real conducive to a wired network. So now with wireless, you can get into those areas. And even if you were trying to wire those hard to reach areas, it was expensive to get all the cabling and all the wiring done. So now with the wireless LAN, you can just set up the access points and off you go. So now getting into the standards. The wireless LAN standard here in the US is the 802.11 standard with several augmentations to that with the B, A, and E. Europe has the HyperLAN 2 standard, and then talk a little bit about the interoperability issues with all of these existing standards. So a brief background of 802.11, first published in June of '97, operates in the 2.4 gigahertz frequency, which is the same frequency that all your cordless telephones and everything operates in, and is a very crowded frequency. Only had 1 to 2 megabits of throughput, which didn't make it very conducive for enterprise implementations because you need much more throughput and bandwidth than that. And then for communications, it had several modulations that you could choose from. So in late '99, they added a supplement to 802.11, 802.11b. And what that did, it increased the speed from 1 to 2 megabits to 11 megabits, which made it much more ideal for companies to start looking at the technology and see that it might be a good thing to implement. And then it changed to only use direct sequence modulation. And then, of course, 802.11b is what is most widely deployed today. So at the same time that the 802.11b standard was introduced, they also introduced 802.11a. And what that did is it moved the communication from the 2.4 gigahertz to the 5 gigahertz, which is a much less crowded frequency. But one of the issues there is you also get less distance from access points to clients. So you need more repeaters. And it changed to orthogonal frequency division multiplexing for communication. But it also increased the data rate to 54 megabits. And right now there's no products currently available for 802.11a, but those are expected later this year, hopefully in the 4th quarter. So what's upcoming for the 802.11 standard. Right now they're working on 802.11e, and what that does is it's really trying to improve some of the security issues in the standard itself, and some of the extensions will be to the MAC layer, longer keys, key management systems, getting into a more dynamic key management system, and also adding 128-bit encryption with AES. So what's happening over in Europe is they've developed the LAN 2 standard, and really it's very similar to 802.11a. Operates in the same 5 gigahertz frequency, has over 50 megabits throughput rate, and also uses the orthogonal frequency multiplexing. So with all these standards, do they interoperate? No, of course. Nothing can talk to each other. 802.11a and 802.11b, since they operate in different frequencies, can't talk to each other, but they can exist on the same network. And I know some wireless vendors are working to develop access points that have both 802.11a and b antennas, so you can have those two standards working on one network. And LAN 2 is not interoperable with any of the 802.11 standards, so it will be interesting to see in the future which standard does become worldwide standard, if anyone is chosen at all. So now I'm going to talk a little bit about functionality, basic configuration, and what the major components are of a wireless LAN implementation. Talk about how the communication works, and a little bit about the packet structure, because it is a lot different than what's used in normal Ethernet networks. So basic configuration, everybody's probably aware of. You have your clients using a wireless NIC. You have your access point. You can plug that into a router, hub switch, which then connects to company intranet, to the internet, wherever you want. And you can always have the little sniffer out in the parking lot. And we'll talk about that in a minute. So 802.11 communication, how does it work? Well, as everybody's aware, in Ethernet you have the carrier sense multiple access, or CSMA, CD, collision detection. Well, 802.11 uses CA, or collision avoidance. And the main reason for that is there's two. One is a wireless LAN adapter cannot send traffic and cannot receive traffic at the same time. So the way collision detection works is it's sending and listening to see when there's an open space on the network. Since a wireless LAN can't do that, it doesn't know that when it's sending traffic that it really isn't supposed to be sending traffic. And then there's also what's called the hidden node problem. And the solution that everybody came up with, collision avoidance, uses a four-way handshake. So what's the hidden node problem? What that is you have an access point, and it has a wide radius of where clients can connect. And then you can have two computers that are both connected to that access point, but they could not overlap, so they have no idea that each other exists. So if you're trying to use collision detection, node A has no idea that node B exists and wouldn't have any way of knowing that it's actually trying to send data to the access point. So the four-way handshake that got around that problem is you have the source and the destination, and the destination can be an access point, or if using a peer-to-peer network, can be a wireless NIC. And what the source does is it sends an RTS, or a request to send. And if the destination is open to receiving communication, it sends back a clear to send packet, or CTS. And when the source receives that, it says, okay, I can send my data, so it sends it on, and then the destination sends back an acknowledgement. And this is for every data packet that is sent. So this is how it gets around having to consistently listen and know when to send and receive data. So a brief look at the OSI model and where 802.11b fits in, where the packets fit in. The physical layer, there's the physical layer convergence protocol header, and then above that in the data link is the MAC header. And we'll look at those right now. So this is your standard Ethernet packet. This is the data. If you look, it has a 14-byte header. It has a destination address, a source address, and some protocol information. Now if you look at an 802.11 packet, it has a 30-byte header. So already your network overhead is far greater than just using normal Ethernet. And it has 4 address spaces, and the reason for that is for roaming. So you have your source and your destination, but if you're roaming from access point to access point, the wireless network needs to know where to forward those packets that it received from the previous access point to the new one. So it has 4 address spaces to handle that. And those are the packets that sit at the data link layer. Now getting down to the physical layer, this is your Ethernet packet. You're just looking at the preamble as an 8-byte header. Pretty simple. Then you look at the 802.11, and it has a 24-byte header. And the biggest portion of that is the synchronization portion, which sits in the physical layer convergence protocol. And that's what controls the communication. Everything has to be synchronized between channels and nodes, so it knows how to communicate with the access point. And part of that is this header and this part of the packet is always transferred at 1 megabits. That's to help ensure that it actually gets there. As the faster you go, the more interference you get, and the more errors that you are likely to receive. And another thing that happens in 802.11 is as you get more and more interference on the channel, the standard starts fragmenting the packets more and more, making them smaller. So even though you're having more and more fragmented packets, you're getting much more overhead because the packet header is so much greater. So you're getting more and more of these packets sent at only 1 megabits with greater overhead. So your network throughput drops drastically. So that's just one QoS concern to look at for a wireless network. So understand now a little bit about the communication process and how wireless LAN works. So now I'm going to go into some of the security issues and solutions. So the first three here, the sniffing and war driving, the rogue networks, and the policy management, are some of the main issues that we have right now in security with wireless LAN networks. And in the standard, MAC address, SSID, or service set ID, and WEP are what are talked about and used right now to secure these implementations. And I'll discuss a little bit about why those don't work very well, especially in larger enterprise organizations. So war driving. It's got a lot of press recently. I know the Wall Street Journal did a big cover story on it. People driving around, sitting in parking lots, being able to access wireless networks. And why is that so easy? Mainly because default installations of wireless networks are very insecure. They allow any network card to access the network. You can see everything, you can do everything, and it provides direct access behind the firewall. Much like radius dial-in implementations from yesteryear, get access to the network, you're behind the firewall, you have complete access to whatever's there and that you can see. And even besides just using a laptop, there's been reports with using big dish antennas that you can sometimes get up to at least an 8-mile radius of wireless networks and pick up the traffic. One thing back on the war driving. One way that you can sometimes pick up on knowing when somebody's trying to get into your network is, especially if you're using a wireless LAN sniffer. I know World Packets has one. There's the sniffer one, and I think you can also use dsniff or TCP dump. And if you can monitor your traffic and see somebody coming in with an SSID that's not on your network or trying some of the defaults from different vendors, then that's probably a pretty good indication that somebody's just trying to get into your network. And so rogue networks. Since there are all the nice accessibility and convenience of a wireless LAN, much like setting up their own rogue dial-in modem, employees will send them up so they can wander around their office or wander around their building and have network access. But a lot of them aren't very much aware of the security issues, so they don't worry about that, they don't deal with it, they don't think about it, they just plug in their network and off they go, they're happy. But then you're concerned about, you can still have war driving. Even though you don't know about the network, you can still go and be vulnerable, so you have your nice false sense of security, which is very dangerous. And one way that you can detect rogue networks is every access point has its own ID, much like a MAC address. And if you're monitoring your wireless traffic with one of the sniffing products, you can monitor all these access point IDs. And you can have a list of the ones that are valid for your organization, and if another one pops up that shouldn't be there, then you know that somebody's installed something that shouldn't be on your network. So the final main problem is policy management. When you turn on a wireless LAN network, it's binary access. You can have complete access or you can have no access. So for most large organizations, you don't want everybody to have access to every part of your network. So you need some way to be able to monitor that or control that and be able to control which portions of the network they can have access to. So what are the ways to get around these security issues? Well, as I said, in the standard, there's 3 that are discussed and 3 that are mainly used. The MAC address, the service set ID, and WEP for encryption. So in the MAC address, pretty much all the wireless LAN access points that are sold today, you can control address or you control access by MAC address. You can say only these 5 MAC addresses can access my network. Well, that gets very cumbersome when you get up to more and more users and installations, and having to keep track of that is very difficult. And also a MAC address can be spoofed, either through the driver on the client. You can change it, you can spoof, and they're easy to get access to because the MAC address is written right on the outside of all the wireless NICs. And also, if you have a situation where you don't know who's going to be trying to access your network, you can't use MAC addresses because that's impossible to know who's coming and who wants to use. And that's mainly for the public access, like here at Black Hat and in airports. You don't want somebody to have to go contact you ahead of time and say, hey, I'm coming, I'm going to be there, I don't know, sometime in the next 2 weeks, so set up my MAC address. So the service ID is really, it's the network name for the wireless network, and it's used a lot of time as the password. And there's common defaults, 3 comms is 101, Cisco's a Tsunami, and most people don't change those. So if they're just using the SSID to get onto a network, it's very simple. And the problem is, the more people that know that SSID, the more likely it is to get out. So it's easy to go through and have the sniffing in ward driving, just have somebody sitting knowing what your SSID is. And then also, to change the SSID, it has to be changed on every single client and every single user. So if you have hundreds of users, going through and having them change all of that is difficult. And most people don't really want to change it themselves. So then using WEP for encryption. Well known, lots of issues with WEP. Ian Goldberg did a great presentation yesterday on what the issues are with there. And there's a presentation going on right now on how to crack WEP. So I'm not going to go into that, just say it's not very good to use. The biggest problem is that besides all of its cryptography issues, that when using WEP, every user has the same shared WEP key. So the more users you have, the more probability, the higher the probability is that that WEP key will be linked to someone. And then also when you want to change the WEP key, you have to change it on every single client, every single access point, which is time consuming and difficult, especially if you have people traveling, don't come into the office very much. So now I'm going to go into some of the configurations and implementations and tricks that I've seen on ways to secure wireless LANs, and break it down into 3 areas. Just a basic configuration for small networks, intermediate for mid-sized companies, and then getting into the enterprise setups for larger organizations. So a basic wireless LAN, small environment, 5 to 10 users. You can use WEP. Even though the standard has a 40-bit key, some vendors have implemented 128-bit proprietary implementations. The only problem with that is you are stuck to that vendor. For example, if you're using Cisco, somebody brings in an Intel card, they are not interoperable on 128. You can't use that high-level encryption. You can also specify MAC addresses. You have a small enough user pool that it is easy to go and change all that. And the best thing, if you are using this implementation, is to rotate the SSID and the WEP keys every 30 to 60 days. And this is the most inexpensive solution. Don't need to purchase any additional hardware or software besides what's needed for the wireless LAN. So here's just a basic architecture. You have your users and you have your access point. Very simple. So one thing that I've come across is SLAN, and it's an open source VPN type solution that is great for securing small, medium-sized wireless LANs. And it's available, if you can see at the bottom, slan.sourceforge.net. You can download it, read all the documentation. But it's similar to a VPN, but it's interoperable on cross-platform, supports Linux and Windows right now. For the client, server runs on Linux, and it provides server authentication, client authentication, dynamic keys, privacy, integrity, everything you really want to use. Only issue is it's not that scalable. So your basic SLAN architecture looks a lot like a VPN, which I'll talk about in a minute. You have your client, access point, and between the access point and whatever network you configure it with sits your SLAN server. So how does SLAN work? And it's the 5-step process, and I'll go into this a little bit just because I think it's a really good tool that a lot of companies should look into using if they're really trying to get a secure wireless LAN implementation for small to mid-sized group. Starts off with the client-server version handshake, make sure they're all talking the same language. Then it does a Diffie-Hellman key exchange, and it uses Blowfish right now, set to use AES and a few other algorithms in the future. Then it does server authentication, uses a public key fingerprint to make sure that the client's talking to the right server. And then the server can authenticate the client, uses Linux PAM, so you can do user ID, password, or whatever other PAM modules that you have. And then it goes into the IP configuration. You can set the SLAN server to use a pool of IP addresses, similar to DHCP. SLAN doesn't have DHCP support yet, but they're planning to add it in the future. And then it adjusts the client routing table. And why it does that is, what happens is, on the client, it installs the SLAN driver, which is very similar to a lot of VPN drivers. Kind of shims itself in between the OS and the physical driver. And so what happens when the client's using it, say they're browsing the web, sending email, the plain text traffic goes into the SLAN driver. Now what that does is it forwards all that communication to a user space process, and in that process is where all the encryption occurs. So it comes out of that process, gets sent to the physical driver and all the encrypted traffic, which is then forwarded onto the SLAN server, where the traffic's decrypted, and then sent off to whatever network it needs to go. So all of the traffic on your wireless network is encrypted. It's authenticated with dynamic keys. Right now, the default installation of SLAN keys are renegotiated every 60 minutes, and that can be changed to whatever you want. So moving on to an intermediate wireless LAN. This, I've said, is about 11 to 100 users, and that's because a lot of these wireless solutions aren't very scalable, so getting into up to 100, 150 users, it's a little hairy to administer. If you're on the lower end, you can still use the MAC addresses, the WEP, rotate the keys. It's available. You can also use SLAN. One thing you need to watch is the MAC storage and the MAC address. A lot of vendors have limitations on the number of addresses that can be stored. So if you reach that limit, then you need to look into some other solution. And finally, what's probably the most conventional solution right now is tunneling all your wireless LAN traffic through a VPN. So here's one wireless LAN intermediate architecture, and this is using MAC addresses. And what I've seen here is you have the wireless client connects to the access point, but before they can even do that, the user has a barcode on their wireless NIC. So you have to go up, scan their wireless NIC into the barcode scanner, and what that does is it runs a script and it adds the MAC address to an access list on the access point. So now they have a dynamic way of knowing who's going to be in the office, who's going to be able to connect to the network. They can do that, and then every night that list is emptied. So the next day you have to go back in. So it's one way to automatically control that MAC address list, not have to have administrators and communications beforehand. So talking a little bit about regular old IPsec VPNs and how to use them with wireless LANs. It's more scalable, especially a lot more scalable than the SLAN solution, even though it's a similar type of solution. But it does require a lot of knowledge and a lot of configuration of VPNs. It also requires a lot of clients work and being able to install VPN clients and manage those VPN clients on all the users. And another issue is roaming. If you're roaming, you need to re-authenticate between every access point, which can be cumbersome. So here's one VPN architecture, and this is just placing the VPN between whatever network and you want to connect to and the access point. And this also shows if you have multi-access points, when somebody's roaming between them, they have to re-authenticate to the new VPN. And some of the standards, which I'll talk about in a minute, deal with the roaming issue and make it to where users do not have to re-authenticate themselves. And here's another VPN architecture. This one is treating the wireless LAN almost like a DMZ, sitting in its own network, sitting off to the side, and seeing this used as having authenticated IPsec clients being able to access the internal network, and you could have guests and other users just being able to come on and access the internet and controlling all of that access right at the firewall or VPN gateway. So moving on to the enterprise. This is the 100+ user range. Getting into this many users, reconfiguring web keys is not feasible. Keeping track of MAC addresses is not that feasible. You have multiple access points, multiple subnets, and some of the possible solutions here: VLANs, continuing using VPNs, some custom solutions, and then the upcoming 802.1x standard. So using VLANs, what this does, you can combine all your wireless access points into one network on a VLAN using the 802.1q VLAN tagging. And then adding a VPN gateway for authentication and encryption between that. So here's a sample architecture. You have the VLAN 2, the red dotted line, which is all the access points, and the one router gateway, which can control access to all the other subnets, all the other networks. And as a user roams from access point to access point, they do not have to re-authenticate themselves because everything's controlled by the one gateway. And customized gateway solutions. Really, with the wireless LAN, you're only limited by your creativity and what you can do to set up some type of security measures. One of the best ones I've seen is at the Georgia Institute of Technology, and they use a combination of VLANs, IP tables, a web browser, and Kerberos. And the great thing about this one is there's no client configuration. Nothing has to be done on the students' laptops for them to access the network. So what happens is, student with their laptop walks into the network, wants access, turn on their system, they get an IP address through DHCP. But the only thing they can do at that time is they can open a web browser to one page, and what that is an authentication page where they enter their user ID and their password, which is then forwarded on to the Kerberos server. And if authenticated, Kerberos server replies back, okay, everything's great. And the Unix server running IP tables, there's a script that runs that adds that client's IP address to the IP tables and gives them access to the network. And when they leave the network, that IP address is deleted from IP tables. So with that, there's no encryption in this solution. This is just mainly allowing access. And this is a good solution for a lot of wireless providers. It helps control people from stealing their access, which is for them losing revenues. So talk a little bit about 802.1x. This is the big topic of conversation right now. It's the upcoming standard in draft form right now. And what it will do is, using Radius and EAP, the Extensible Authentication Protocol, it will hopefully eliminate some of the issues with WEP in standard form, instead of having all these point solutions that people are using right now. And it will also allow for dynamic key exchange, stronger cryptography, and transparent roaming. So the standards in pretty much final draft form right now, could be implemented as early as 2002. The Cisco AeroNet products already support the draft version in their 350, and Microsoft will include it in XP. So just a pretty basic architecture of what 802.1x would look like is you have the client, which is referred to as a supplicant, and using EAP over LANs, it would communicate with what they call the authenticator, which most likely would be an access point. And what that then does is it forwards an authentication request over to a Radius server, and it supports user ID passwords, smart cards, digital certificates, a wide variety of authentication schemes, so you can have whatever authentication level you want. Just basic, you want two-factor, strong authentication. So once that authentication gets to the Radius server, it verifies it. If it's okay, it replies back to the authenticator, says yes, everything's great. The authenticator then opens up the ports and allows the client to communicate to the network. So in the meantime, when you're waiting for 802.1x, besides some of the custom solutions and SLAN, there are some third-party proprietary products that do exist that will give you the same types of technology that 802.1x will provide. NetMotion Wireless has one that allows you to authenticate directly to a Windows domain, better encryption than WEP. And one of its nice features is it allows you to remotely disable a wireless network card. So if you see somebody doing something fishy, you can disable their access. Fortress has developed what they call their wireless link layer security, which is similar to TLS. It works with 802.1x, improves WEP's encryption and cryptography features. And then Enterasys and Cisco also provide proprietary 802.1x type solutions. And one thing you can't forget is the client considerations. Just like a regular old VPN implementation and any other network implementation, your client is a weak point. So even if you have your network all secured, people can't sniff it. You've got authentication. If somebody gets hold of your client, game over. So distributed personal firewall, strong security policies, strong configurations, keeping up to date with patches, all the stuff that's normal for security. But also one of the big things is laptop theft control, especially if you're using web shared key. If that laptop disappears, your key is compromised and you have to go through and change everything as soon as possible. I talked very fast this morning. Whoops. So, in conclusion, wireless LANs are very useful, very convenient. There's still a lot of security holes in them. There are ways to get around that. It will become much easier once the 802.1x standard is in place. And there's some figures just to show the growth in use and popularity, up to 2.2 billion in 2004. So I added a lot of slides to what's in the booklet, and you can, besides get the presentation from Black Hat for download, it's also available at arcsec.com and will be available at survivingsecurity.com, which is the companion site for my book, which is on the shelves next week. And my email address, if you have any questions, feel free to email me. So any questions about wireless LANs, implementations, solutions? The question is, right, the question is, if you have an existing infrastructure, what happens when 802.1x comes out? Do you have to buy all new equipment? And from what I understand and from what I've heard talking to some of the vendors, it will be just a firmware upgrade. It won't require you to purchase all new access points, or at least I know they have that capability. Whether or not they allow you to do that is up to them. Because for them it could be a great revenue increase if they just say, we have to go buy all new equipment to get that. But they can do it in a firmware upgrade. Any other questions? Way in the back.
Do you have any experience in your impressions about wireless security?
The question was if I have any experience on PDAs in wireless security, and the answer is no. Not at this time. I'm sorry, I can't hear you. The question is if I've seen anything like Tempest related to control emanations, and I have not. Have not heard of anything dealing with that. It's a good idea, maybe something to look into. Anything else? I'll be up here for questions if anybody wants to talk.